Welcome in to the Energy Tech Podcast, where today we are joined by esteemed guest, Arlen Nipper, and he is here to talk today about the future of MQTT and oil and gas. I'm joined in as well by my co-host, Mike Flores. Guys, welcome to Cannonsburg this morning.
Hey, Jeff, thanks for having us. This is going to be an excellent episode. I am your co-host, Mike Flores, with the Energy Tech Podcast here in Cannonsburg, Pennsylvania, as part of the OpSite Energy Control Room. And you're right, Jeff, this for us is a big treat to have someone that is a key piece in the industry, if industrial automation in every vertical, I think, right now, with his impact. That's Mr. Arlen Nipper. Arlen, glad to have you on the show.
Hey, guys, thanks. I'm looking forward to it. This is going to be great.
Yeah. Oh, man, it's so exciting to have you. You know, Arlen, just getting you here, I think, is a great opportunity. I think this is going to be the highlight. We're essentially covering this. You know, if you're tuning in, we want you to ask questions. Don't forget to hit the like button. But most of all, we're going to be putting this out there in a series because we captured Arlen's time here in Cannonsburg. And our focus, of course, is being connected by design. And as Jeff pointed out, the future of MQTT in oil and gas. And I think what Arlen's going to uncover a little bit is the story where even its origin of MQTT and how it was born in oil and gas. So we'll get to that. But Arlen, you know, when I met you, it was a few years back at the Ignition Oil and Gas Conference. And for those of you that don't know, this is a group of oil and gas peers that get together and discuss the challenges, the deployments, the key factors that improve ignition as a whole. And part of that in that ecosystem, of course, is MQTT and other different protocols and products. And I met you, and I was with I was with the systems integration team at IDM, who's one of our partners here at OpSite. And we were looking into some data aggregation, and you came up to me directly and said, time out, before you do all that, I want to talk to you about something. And it wasn't just MQTT, but it was the dimension you brought and the knowledge of experience. And so I thought that was a big deal. And ever since then, just following you in the industry has been very helpful. And I just want to know, how long have you been in the industry doing this?
Well, let's see. I started, actually, I went to Oklahoma State.
Yeah.
Started as an electrical engineer.
Yeah.
And about 2 years in, I'm going, whoa, this is boring. I don't know what I'm going to do when I get out. And you know, we'll go through that later on helping, you know, engineers and technicians, you know, kind of get up to speed. But I was going to quit, and I was on my way to my advisor's office, and there was a notice on the bulletin board, and it said Amoco Oil Company. That was back before it was spelled BP Amoco.
Yeah.
Had a summer intern program. So I got over there, and I still remember all the guys that were there. Really great guys. Joe Vitale ran the engineering department. He said, "Hey, we've got a new department. It's called Microprocessor R&D."
Wow.
Okay, I got there, and Tony Cox was the head engineer. He said, "Hey, Arlen, we're working on this project for a downhole gauge, and RCA had just come out with the first ever CMOS microprocessor. It was a 40-pin dip, and it was called RCA 1802. So that summer, I got to wire wrap it, you know, no circuit boards, and we would program it using literally our, you know, 1802 machine language, and that would go to the IBM mainframe, which would, I don't know, 30 minutes later, would take the binary and burn it onto an EEPROM. We had 2K EEPROM, and then you'd plug that in and see if your application ran. Basically, you had 3 LEDs to kind of troubleshoot it. And, you know, if it didn't crash, you know, start over. But literally that experience, I came back to Oklahoma State, and I go, I know exactly what I want to do.
Yeah.
So that was, you know, 78, 79 time frame.
Wow. So you've been in this industry that long, and, you know, part of what we're going to do, right, is just, you're going to take us through that journey a little bit. And, you know, you did a fabulous job here. One of our partners, CNX Resources, yesterday, you really covered the deployment of Ignition and leveraging Ignition and cloud data, leveraging IoT Bridge and MQTT. And I think you made some real impact in that meeting. We had the Chief Operating Officer for CNX, Navneet Bell, Chief Technology Officer was in there. So the leadership group and the data engineering group and your automation group was there. So I think you had some lots of mind changing that happened there. And in a minute, I want to get in that story, but you've intrigued myself as well as Jeff, right, Jeff? I mean, I think Arlen, you intrigue us not from the technology side, Arlen, just why you're doing what you do, because I mean, at the end of the day, MQTT is we're going to discover here is it's an advent product that's being deployed everywhere in lots of verticals, and but me personally, because I have you here, I just want to know, like, you obviously love to do this, but why do you like to do it? Because a lot of folks want to hear the why. We hear about the technology. I hear about the technology all day long.
Yeah.
Got to be about the money.
Right? No. Yeah.
Yeah, all that royalty I'm making on MQTT.
No.
We were actually talking about that last night, and I was like, and I wonder how that played out, but probably none of my business either way. But yeah, very interesting. Having dinner with you last night, Arlen, and kind of going over the genesis of MQTT yesterday with the teams that Mike mentioned. So it's great to have you here. I echo Mike's sentiment, and we'd love to see what your why is.
The why.
We're going to capture you here today for quite a bit of time, but that's one good question, Mike. Appreciate that.
Yeah, no, yeah. So Arlen, we'll kick this off. I mean, I want to kind of start the journey. And again, if you're a listener, we want you to join us, and we're glad if you're the SCADA guy, if you're the automation tech, you're very familiar with MQTT deployments of things like Node-RED. You have lots of familiarity. But if you're listening to the show right now, for us, this is the opportunity for Arlen's going to walk us through that journey and how it started, and the prolific the prolific growth of MQTT right now.
Okay.
And so, Arlen, start us from the beginning. I mean, there was that point you did talk about, hey, early 1970s. I this is where I started, but you came to a point where, hey, the MQTT was born out of. We'll talk about that in a second, but start from the beginning. I mean, that's an important piece.
Well, so kind of, my career, it just kind of led up to the invention of MQTT. So when I got out of college, went to Coke Oil.
Okay.
So I was raised on a farm in Medford, Oklahoma, but Coke had a refinery in Medford. So we would bring raw feed in from West Texas, Western Oklahoma, Southern Kansas, and bring that into Medford, and we would fractionate it. And Medford set over a salt formation. So we had, we could wash out caverns. So we had a lot of storage there. So really, I got to Coke, and the first thing is like, well, what do I do? And I go, well, we've never had an engineer here. So you just go out and ride around with the guys and see what there is to do. Well, about that time, the ethane market took off. We literally, up that time, we were flaring ethane because there was, nothing to do with it. It was high vapor pressure. But we were told we needed to build a pipeline from Medford to Mont Belvieu, and we need to do it in a year. So I was out in the field. I got to do everything from run the ditch witch, putting the conduit in the ground, connecting up 5,000 horse Westinghouse motors. Toshiba had just come out with vacuum tube starters, instead of the old oil wetted contact starters. Then, the Modicon had just come out with the 484 PLC. So it was the size of a, small dorm refrigerator. Got to program the PLC and then connect that to a Tano RTU, connect the Tano RTU to a 300 baud FSK modem, and all of that multi-drop circuit went from Medford all the way to Mont Belvieu, and we had a PDP-11 that was running our SCADA host software. So, I got to learn about 4 to 20 milliamp transmitters. What are they? Why do we have 4 milliamps instead of 0 milliamps? Learn about PLC, learn about communications. What is a poll response protocol? Why did we have to, actually poll these devices? So I learned a lot, but I also, there was a lot of other things that interested me. So at that time, Honeywell came out with the first smart 4 to 20 milliamp transmitter, and it had a protocol called HT 2000. So at home, I wire wrapped a multiplexer that could multiplex 16 of these smart transmitters together and then talk Modbus. So I thought that was pretty cool, and a engineer from Kansas City at the time was starting a little integration company called Novatech. We took that idea to Honeywell. They started us off with like $1 million of funding to get that out there. So that was kind of moving from working for an oil company to, okay, more product-based, let's go start a company. Yeah. Well, that was ultimately acquired by Arcom Control Systems out of the UK, and they did single-board computers. So initially, Novatech was bought as a presence in the United States to sell single-board computers. And I found that was very frustrating because you would go out, you have this little green circuit board, and you put it in front of a customer, and we say, hey, this is the latest CPU on there, and they would look at it, and they would go, well, Arlen, what if we take that chip off? Can we save some money if we take that chip off? Well, we're not going to be using RS-232. So, but taking what I had learned at Coke and knowing that there were still people using protocols, and at the time, this is now the, late 80s, early 90s, we had all of this 1970, 1980 legacy SCADA systems out there, and people were looking to upgrade either the devices in the field or upgrade their SCADA host system. So we started writing software to run on these single board computers, and we made protocol converters. So it was ironic. I could have a green circuit board that I couldn't sell for $200, but if I wrapped it in a $50 case and made it do something interesting, I could sell it for $3,000.
Yeah.
So
that packaging analogy, if you repackage that, you'd be interested. People tend to buy.
Yep.
Yeah.
So we did very well at the kind of the height of the mid 1990s. Arcom probably had 65-70% of all the midstream pipelines were using our protocol converters to interface legacy equipment to newer SCADA or new equipment out in the field to old legacy SCADA. And I think if I put a slide up the other day, but I think if I remember right, we had like 120 different protocols that we had implemented, everything from old bit synchronous protocols. And, if you think about it, when oil and gas first started automating, there was no such thing as RS-232. UARTs had not been invented yet. So what they would do is literally clock data onto the wire. And so a protocol like an old TANO bit synchronous protocol might be, okay, here comes 142 bits. And it would just clock in, and then you had to take those 142 bits and take them apart and go, okay, the analog's there and the digital input's there. So again, we came up with ways by high-speed sampling with the CPU, we could emulate those protocols. So all that was very good, but all this time, remember, our infrastructure for SCADA, for oil and gas, was primarily AT&T multi-drop phone lines. AT&T were heavily subsidized. When I worked for Coke, we had a tank farm that we had built out in Stockholm, Oklahoma, and AT&T had to run 27 miles of 4-wire circuit. But hey, they were subsidized. They could do that. And the reliability was great. If I had a problem, one of my remote stations stopped talking, I could call Toll Test in Oklahoma City, and they would help me, ping the circuit, try to fix it, see if it was water, see if the circuit had been cut. So life was great. But at about the same time, another thing happened is the government decided to basically break up AT&T. And when they did that, all of those local telcos, like my pipeline from Medford to Mont Belvieu, now every little town along the way became its own little phone company. Yeah. So instead of calling AT&T, which they knew exactly what was going on, I had, excuse me, I had to call Conroe Telephone Company and say, hey, my 1200 baud modem doesn't seem to be working. Well, what's a modem? Yeah. Right? So what happened there is now the VSAT vendors kind of all came in. We had Gilat, Scientific Atlanta, GE SpaceNet, AT&T tried them, and what they were offering is we could put very small aperture terminal, VSAT, and a ground station there and connect our equipment in, and then be able to talk over the VSAT back down to their ground earth station, and then backhaul that data back into the SCADA host system. So we had to play some interesting games where now we had all that propagation delay, so we would build virtual databases, a virtual RTU locally at the host. We would poll out in the field, take that data, send it over the satellite, and then spoof it back to the SCADA host system. So again, all worked very well. We had a huge customer base out there that were using basically all four of those VSAT systems. And really the problem there was, we were talking proprietary protocols out in the field, but everybody, GE, SpaceNet, Scientific Atlanta, all had proprietary transport protocols to get the data over the bird.
Right.
So now we were doing several layers of protocol conversion. Then 1998, AT&T Tridem finally came out with their infrastructure for their VSAT system was based on TCP/IP. So I think what a lot of the listeners have to understand is that if you were doing anything with SCADA in oil and gas, anything, you were using DEC computers, you were using DECnet networking. Everything was DEC. Originally it was PDP-11s, and then it went to VAX computers. But in 1998, TCP/IP wasn't that prevalent at all.
Right.
So Steve Koenig was the SCADA manager for Phillips 66, and we had our old protocol converters in there, right? You still had to pull over the VSAT, and space segment was very expensive. So when you bought your little chunk of space segment on a satellite system, you were looking at hundreds of thousands of dollars a year of communications costs. And the fact that we were polling exacerbated that, because if you think about it, any poll response protocol consumes 100% of the available bandwidth.
Right.
Guaranteed. If you think about it, there's nothing else you're going to do within that bandwidth because you're going to consume a poll response. So Steve Koenig was a good friend with the IT director at Phillips, which is, kind of ironic. We're talking now about IT versus OT, and here the SCADA guy and the IT guy were actually very good friends. And he said, hey, Steve, we're using this new IBM technology. It's called message-oriented middleware. And IT at the time, or today, I think we all know it as enterprise service bus, is that what IT were starting to do is instead of writing applications that were hard-coded to each other, they would decouple them by publishing that information to a broker, and then other applications could subscribe to that. So you've decoupled. Your producers don't care who your consumers are, and your consumers may not know who the producers were. So Steve was looking at this, and he was very interested. He said, "Arlen, could we do the same thing with SCADA? Could we just like publish information from the edge, and then have a quote SCADA broker?" We didn't know what the name of any of this was going to be. So at the time, IBM actually had a research facility in Hursley, UK, and the head research scientist literally was saying, we should apply this big, heavy MQ series, but we should start getting out into OT. And he actually had 1996, 97, he had diagrams of MQ out in SCADA and telemetry.
So in this relationship with IBM, Arlen, was this like, hey, we want you to meet so-and-so and we want to introduce you to Arlen, or was this by chance? Like, how did that evolve?
It was 100% serendipitous. I mean, Andy Stanford Clark was with IBM, and he was in the States for some reason. I can't remember what it was, but we basically I met Andy Stanford Clark in Steve Koenig's office in Bartlesville, Oklahoma. He introduced us, and IBM had allocated his time to see if we could make Pub Sub work over a VSAT system for a SCADA system. So here you had Andy, completely 100% came from IT, all of that. I'd been doing at this point, I'd been doing SCADA for 20 plus years. So we literally got together and we looked at big MQ, and that was a no-starter. The header on MQ was several thousand bytes. And we were going on the basis of every byte that we could save on the overhead of the transport would be another $50,000 a year to Philips.
So you felt like your decision is informed now because you recognized the Philips 66 and its remote but critical operation, right? I mean, does that kind of inform your thoughts that, hey, here's a remote critical operation for Philips 66, and you're saying if we can take this protocol and we can reduce the byte size, then we're cutting out cost, but at the same time, we're reducing that total bandwidth if we can help it, and we're saving dollars for this critical remote operation, right?
Right, exactly. So, we had to sit down and kind of come up with some parameters there. First thing is it had to be simple.
Right.
We're running on 8-bit Z80s with 64K of memory. TCP/IP stacks they were in their infancy at that time. So it had to be simple. It had to be efficient. Bytes on the wire. It had to be bidirectional because we had to be able to send commands. So, ultimately now people look at MQTT and there's a lot of, Arlen, that's just publishing data in. They have to realize it's Pub Sub, it's bidirectional. And the critical part of it is that it had to be stateful. So here's where I'm going to kind of like dive off. You've got to know a little bit about TCP/IP. So you kind of the mechanics of establishing a TCP/IP socket that's persistent. Okay, great. And now I can publish data anytime I want. It's not like I'm round robin polling. So again, if you think about it, in
an open highway.
Yeah, in conventional SCADA, I'm sitting here, I'm the host, I've got 100 remote locations out there. I'm going to poll that one, and then I'm going to get maybe 3 or 4 polls, and then I'm going to move the next one. I'm going to poll that one, and then I'm going to move. And by the way, there's stuff happening over here at the first one, but I don't know about that until I go all the way around and come back to the first one again. So we wanted to eliminate that, and basically our protocol converters, if you will, we're doing the high-speed polling at the end, and then with MQTT, we could just take all of that data and publish it. But then, and we hadn't even put in, the notion of a last will and testament, but we're going, okay, well, report by exception was great. We reduced the bandwidth that Phillips 66 by like 95%,
Right.
literally. But how do you know? Okay, report by exception only works if you know there's something there that's going to tell you that something happened. Right. You have to trust that, right?
Right.
And so that's where we built in the last will and testament at MQTT. So the broker was responsible for publishing a death certificate anytime any of my nodes in the field dropped off, right? So it could have been rain fade. Rain fade came through, that site went down. Now my job in the SCADA host, right, at the time we were using an Aviva Oasis DNA system, we had to force all the tags stale so the operators would know, hey, that particular site just went offline. So Andy and I, we prototyped it, we tested it, we did some more prototyping, and ultimately we released the 3.0.0 MQTT spec in 1999. And Phillips has been running on that for the last 27 years, 26 years.
So in from that serendipitous moment, right? Because that's what it sounds like to me. Here's this serendipitous moment that you have. Your informed thoughts based on oil and gas operations. You have this serendipitous moment. What is that? What's that total time? A couple of years? Is that what we're talking about here? From that time to this version that was released that's still on P66?
Oh no, it wasn't. Yeah. It wasn't years. It was maybe months.
Months. Okay.
Right, because the AT&T were just rolling out the new IP-based systems. So they still had the legacy transport systems out there, but there was going to be a big switch in, okay, we're going to switch from legacy to TCP/IP, and we had to be ready for that.
So Arlen, how did you, again, this goes back to a little bit of why, but how did you change minds there? Because, lots of people see technologies, especially in oil and gas. If I go to a production foreman and I said, hey, if I told you that I could kill your network traffic by 80% and I could help your remote sites operate better and I could do this, there's always the element of trust. I think Jeff can agree to that. You're in the field, it's trust. Is my stuff going to stay up? Because you alluded to that a minute ago about its stateful connection. Mm-hmm. Do I trust this enough to use it in my field? Obviously in between that and the time you deployed this at P66, I mean, wasn't there you had to get minds changed?
No,
right?
that's why I said the entire invention of MQTT, and the fact that it's even out there today, is all down to Steve Koenig. He was the SCADA manager. Now, we didn't come out of the blue. We had already been working with Phillips 66 over probably a 10-year period for all of the different protocol converters.
Right.
So they, Systronics, and then they would come, oh, we've got this old OmniFlow computer. No, Arlen, can you do this protocol? So we had the element of trust.
Perfect.
And then, we tested it and all that. But no, it really was the fact that Al Laurent and Steve Koenig trusted the fact that this was all going to work like we said it was going to.
So not to interrupt and fast forward, let's come back to 1999, but it's 2025. Can you give the crowd a little context on who's trusting this protocol now, outside of industry?
Yeah, it blows me away every day. But I was doing a talk the other day at a university, and I said, hey, if Andy and I would have put a kill switch into MQTT that nobody knew about, and we could go out there today and just kill it, pipelines would stop working, Facebook Messenger would stop working, Instagram would stop working, the large majority of the bank ATMs would stop working, probably more than 50% of the car telematics would stop working, most of the either AT&T, Verizon, whatever phone infrastructure switching management software would quit working. I had surgery at MD Anderson here a few months ago, and the Da Vinci 4 robot that was working on me I found out was publishing MQTT message every time it made a movement change on the robot. So it's
saved your
become it has become pervasive
And prolific. That's a prolific protocol.
Yeah, and several reasons. Number one, it had to be simple. So the entire MQTT spec, if you go look at it, 18 pages. 18 pages. So super simple. You can publish anything you want on any topic. So we didn't put any guardrails around, you've got to use this topic namespace. You've got to use a JSON payload or a Modbus payload or whatever. Completely open. So that has let industry go out, and like Facebook, I'm sure their topic namespace doesn't look a thing like a pipeline control system, right?
Right.
But it was that ultimate, and hindsight's 2020. We picked TCP/IP. Okay, MQTT sits on top of it. So a lot of people read the MQTT spec and they'll LinkedIn or whatever, and they go, Arlen, we can't use this. We just read the spec. You didn't build security in. Okay. Well, in 1998, nobody said, hey, Arlen, Andy, how secure is this?
Yeah.
Right? But looking back now, like you said, look back from 2025, we built it on top of TCP/IP. So guess what? We get to take advantage of any security technology that comes along. So now you've got TLS technology. We get to leverage it. Tomorrow, maybe the best security will come up. Immediately, we'll be able to leverage it. And so that was number one. We used so MQTT doesn't do packet reassembly. It doesn't do security. We let TCP/IP do all of our heavy lifting.
Yes.
And then the second thing is we decided to make it remote originated. So your remote devices make an outbound connection into an MQTT broker.
Right.
So what does that mean today? That means zero trust security. So if I'm out in my field, I'm making an outbound connection.
Only.
So now I could have IT go out and scan all my RTU locations, no ports open, right? And then the only thing you have to protect from a cybersecurity standpoint is a single point on your MQTT broker.
Yeah. So as it stands, then MQTT is the vehicle protocol on the highway of TCP/IP,
right?
And protected by what is today your standard TLS certificates that cover TCP/IP.
That's
basically
correct.
What happens.
Yep.
So it's that simple, and I think that is what IT folks forget and OT folks push. The thinking is it's that simple. It's so simple in its creation, in what you did and what's being done. But so Jeff talked about who's using it outside of the industry. Like it, in my experience in oil and gas, there's still tons of whole response, Arlen, that's out there. I mean, today, if I use paywall platforms like Signet and others, if I want something, I go pull it, right? If I want that, do you think that's still bound in? I want to pull it and see it. Is it? Do you think maybe in the industry it's just they don't know what they don't know, or is it a trust factor? Is it I've done this for so long?
Yeah, it's more and more devices are doing it. So if I look at ABB's new line of flow computers, they're going to be publishing MQTT Sparkplug natively. If you look at Opto22, Wago, Phoenix Contact,
right.
There's more and more. I believe in my presentation yesterday, one of your technicians said, hey, Arlen, Alan Bradley's got an instruction now that's not Sparkplug, but it publishes MQTT. So I think there's just this awareness of that and getting the message out there. I'm working on a white paper blog, whatever now, is that, just to your point, is that if I'm an equipment manufacturer and I've got a protocol like Modbus or even the overhead of having an OPC-UA server on it, but speaking of OPC-UA,
Yeah.
you know, a lot of people think, well, Arlen,
foundation.
I've got to, you know, everything is OPC-UA in my field. And I go, no. You've got a Kepware OPC-UA server. In fact, nothing in the field is OPC-UA. It's doing protocol conversion for you, and you just happen to be using OPC-UA to pick that up.
That's right.
But my point is that equipment manufacturers like flow computer manufacturers or PL, they've got the knowledge. If you think about it, hey, I've got an analog value. I've got engineering units. I've got all of this knowledge that's inside of my embedded device. If I could use MQTT, man, I could plug it in. Boom, there's my data. So configuration would be quicker. You wouldn't have to troubleshoot on the phone. Or, oh, hey, I'm polling this register. Well, or, you know, are you polling it in the right format? Oh, well, I'm sorry, that's a long integer in Modbus, so you've got to put two Modbus registers together, and so on and so forth.
Right. So come back a bit, because I don't think folks get the significance of when you came beyond the serendipitous moment. You launch MQTT. I mean, in the 90s, you know, late 90s, you still had things like HTTP, HTML. I mean, these were somewhat. How does
Well, hang on. HTML, I'll have to look at that, but that was somewhere in the mid-90s. Remember, it was just HTTP, and then this company called Netscape decided, it's kind of like MQTT and Sparkplug. Yeah. They had the transport called HTTP.
Right.
But then somebody came along and said, hey, if we do HTML and tell you what's in the payload, you might be able to build a web browser. And, you know, Internet of People took off. And I think to a large part, we need to, you know, think about that with the industrial Internet of Things, is that it needs an open standard transport, which is MQTT,
right,
and then something like Sparkplug to define what's actually being published back and forth over those messages.
So can you go over the genesis of Sparkplug as well, and what prompted that, and what's the time frame around? Past your 3.0
right.
MQTT.
So fast forward, Arcom got acquired by Eurotech. Eurotech is still around. It's out of Italy. Again, single board computers. So 12 years ago, Chris, my business partner, and I decided to, well, let's get out of hardware and let's just do software. And I was a bit pissed off because MQTT, I say it was invented for OT. It was hijacked by IT, right. And what I wanted to do was get it back down to OT. So we started a Cirrus Link, and we kind of bootstrapped it. And for the first couple of years, we just did. Ironically, we did. I ran seminars training on IBM MQ series for use in oil and gas. And so, but we won a big project for Plains Midstream in Calgary. And we were going through that, and people kind of forgot. Remember, the story started that we were using Oasis DNA for Phillips 66. And at the time that they were Valmet, and then that got sold to Televent, and then that got sold to Aviva. And so by the time we're doing this project, Plains Midstream wanted to go all MQTT, convert everything to, pub sub. And Aviva forgot, or actually they didn't even know that they had an MQTT driver inside of Oasis DNA.
Wow. So
we pulled that out. We blew the dust off of it. We were trying to get all that running, but we didn't have any tools to kind of troubleshoot this kind of like black box MQTT thing. And so that's when I found out about inductive automation. Ultimately, we became their only strategic partner. But to your question, so now we had kind of like vanilla MQTT in Ignition, but there wasn't any interoperability. So we would go to shows, and at the time, I knew Benson Hoagland at Opto22, but he goes, oh, we do MQTT. And then Advantech said, we do MQTT. And Moxa said, we do MQTT. But the problem is, There was no interoperability.
Right.
And so I said earlier, the great thing about MQTT is you can publish anything you want on any topic. But the bad thing about MQTT is you can publish anything you want on any topic. So about 7 years ago, myself, I kind of did the first draft, and then my guys, Wes and Chad and Nathan, all pitched in, and we came out with the first version of the Sparkplug spec. And it literally was our experience, because all of us have been doing MQTT, SCADA automation for the last 20 years.
Right.
Well, we kind of wrapped that up in the Sparkplug spec and said, hey, if you want to do mission critical, real-time operational systems, this is probably a good place to start. And it just formalized how to publish data over MQTT. Hey, you should probably have a birth certificate. So when you come online, you can birth all of your information, and then everything can be report by exception after that. And then come up with a structure so you can have a D command so that when the device receives this MQTT message, go, oh, that's a D command. I should go look at my protocol and send a command to Modbus or Allen Bradley or Siemens or BACnet or whatever. So that really it started as just a sanity for CirrusLink, and then the oil companies got a hold of it and they go, hey Arlen, who owns this? And they go, well, we put it up on our public GitHub site, and they go, no, really. So about 5 years ago, we took all of the IP, we gave it all, the code, the IP, and everything to the Eclipse Software Foundation. So yeah, for anybody listening, we would really like to push vendors and to application providers to join the Sparkplug working group to make it, get it out there.
Right.
We've got software that tests your implementation of Sparkplug to see if it's conformant. We'll tell you if you have any problems with it. The advantage of going through Eclipse Foundation is that now Sparkplug is an IEC ISO international standard, so Eclipse Foundation helped us get that out there. So yeah, it's gone very, very well.
So equipment manufacturers can hop in on the Sparkplug working group if they want to.
Mm-hmm.
And it sounds like what I'm hearing is that take my device, we can walk through that and sort of gain some best practice, some acceptance of the product to make it even better is what I'm hearing.
Well, so if just like you, if you were to buy a piece of equipment and you want to plop it into your ignition system and it says it does Sparkplug, you just want to know that, yes, it really does Sparkplug.
Right.
And have you tested this? And again, we are recrafting right now, joining the Eclipse Foundation and then joining the Sparkplug working group. A lot of people found that very onerous. So we're coming out with a new program that we'll probably be announcing probably a little bit before ICC that makes it much, much easier for integrators to join, companies to join, just, like operators. Right now, Chevron was one of the key members of the Sparkplug working group, all the good work that Todd Anslinger has done and Jose Moldero and those folks. But to get more of the end users involved, because, we're basically in all the oil and gas companies now, but we just need to get them in and help and contribute and support it, because you do need a certain amount of money for the marketing, for the amount of time it took to get ISO, IEC certification, stuff like that. So there is a little bit of overhead that we're just trying to cover the costs on.
Gotcha. So I want to jump to this because I think, as much as you hate the word digital twin, I'm getting the sense that you also have had the same feeling for AI. When I think of digital twin and I mention the word AI to you, I get the same vibe from you about that. And so, I'm sure that listeners want to know, just because it's in top of mind right now, Arlen, how do you feel that, we know MQTT supports that convergence on IT/OT. Do you see it supporting AI at some level? I mean, it's and in your mind, I having talked with you, I think you've stressed lots of responsibility behind it, which is important. But I'm sure I'm not the only one that's approached you with that kind of question. With regard to AI.
No, and really the tenets of us working with inductive automation, with what SeriouSLink, the tenets that we had out there were, if you're going to do digital transformation, the first thing you need to look at doing is decouple. In other words, go as far down into your infrastructure as you can. Don't hard code devices to applications, but connect devices to infrastructure, right? So now we have this infrastructure that is got all of our information in it. So you decouple, and then you work very hard to provide a single source of truth. No longer do we want to go through this Purdue model of, I'm a SCADA system, so I'm going to pull here, it goes into my SCADA host. We have a little application here, and it's going to massage the data a little bit, and we're going to go to level 2. And then level 2, we massage a little bit, we're going to go to level 3. Well, by the time it gets to the enterprise, nobody knows where it came from. The edges are worn off the data. You probably don't even care anymore, right? It's been... So if I go directly from the edge as a single source of truth, now I can guarantee that the enterprise. Now, the third tenet is I want to be able to demonstrate a superior OT solution first and foremost. Forget about cloud, forget about AI, I've got to show a SCADA manager that this is a better, faster, more secure, more reliable, more scalable,
simpler
infrastructure.
Yes.
And if I can do that, now we can talk about cloud or we can talk about AI because I know that I can provide a single source of truth at the next level. Right. And then if I can get to that, then yes, I think that reliably feeds AI.
Right. So, and you've also alluded to that for anyone that's leveraging cloud data too, that what you're really getting to is that you've got to get down and structure especially in Ignition, your UDTs, so that you have great contextualized data on that pipeline or in that unified namespace, right? Yep. So, in other words, what I'm hearing is, Mike, forget about the marathon. Why don't you start by looking down at the edge first before you dive into AI? And it sounds like that's your word of caution to anyone that's looking at.
Yeah, I mean,
AI and big cloud deployments.
There's always this notion of garbage in, garbage out, but man, you could amplify that by 10 million going into AI. So it could be garbage in, catastrophe coming out. So, and again, when I demoed, and there's another, you mentioned the unified namespace. So it was interesting. 10 years ago, I got up in front of an audience at Inductive Automation, and I demoed MQTT Engine. And first time anybody had seen it, right? I said, hey, I'm going to discover 250 PLCs and 125,000 tags. I'm going to do it in about 10 seconds. And I did that demo, and it was, I was sweating bullets, but it worked. But there was this gentleman, they passed the mic around to ask questions. And they passed it to this one gentleman, and they're supposed to ask me a question. Well, he takes the mic, walks up on the stage, past me, and he points at the screen and goes, "This is the future of automation." And that was Walker Reynolds.
Yeah.
So, but what Walker has done, because what's different here with MQTT, when you publish a piece of information instead of polling. With polling, you get one register. Okay, well, now me as a human, I got to make sure I configure it correctly. But with MQTT, especially if the vendors would publish it natively, it comes out and it tells you everything you need to know. And it's a hierarchical arrangement. Well, Walker took that to the next level and said, hey, we should do that and we should call it the unified namespace. So he's done a great job in leveraging what you can do natively with MQTT, but taking it to a whole nother level.
Yeah. So I think that, and that's led to some new approaches in for vendors to demo products, how they deploy their products, even. So, Arlen, what is that? You know, just in terms of the unified namespace, what do you see is so far some of the things that are surprising you about MQTT?
Well, again, so just the adoption of it. I mean, at the, it's like, oh wow, I didn't know these guys were doing this. So Walker had the Prove It conference, whatever, in February this year, and what was it? 40 vendors showed up, and it was like, don't talk about it. You've got to get on stage. You've got 28 minutes to prove it.
Yeah.
And in that, you have to do the demo, you have to tell us how much it costs, and you have to tell us how long it took you to do it. And I think that really brought to light, all of the people that were able to use MQTT were able to plug into the unified namespace. Now, other people were, plugging in differently. They were pulling data from the unified namespace. I know that Benson from Opto22 did a really cool, his contribution, because the Prove It was basically a factory, we'll call it, a fictitious factory that produced printed bagging material like Dorito sacks and things like that. And so Benson basically took all of the compressors, because he knew, hey, this company, they're going to have compressors, right? Well, he has all of those automated at Opto22. They're all publishing information. So he brought those in and he added those into the unified namespace so that now you had real-time compressor information going into this overall unified namespace. And so, yeah, companies like that did all of that. And it was. I think we're really seeing now the power of what you can do with MQTT.
Yeah, and I think you bring it to mind already. If you're in oil and gas, especially if you're a listener, if you're in oil and gas and you have a fleet of compressors, compression in your field, pipeline, facility, production, wellhead data, downhole data that's tracked. It sounds to me like that is the perfect structure for a unified namespace in terms of data.
Oh, absolutely. Absolutely. I mean, again, just in the demo that I did here the other day, taking a Emerson FlowBoss 107 flow computer and literally taking that old legacy rock protocol and being able to get that contextualized and get it into Snowflake. And you go, wow, think about this. I've got a 25-year-old flow computer that, physics don't change. Orifice,
Right.
the differential pressure across an orifice doesn't change. So why tear out a flow computer, just because, and get that completely up into Snowflake and have that single source of truth. So I think it's incredible what we can do with stuff going forward, for sure.
It's
That's
exciting.
exciting.
It's definitely exciting to see all that come to fruition. I'm sure it's been really cool for you.
It's
to
interesting.
kinda see it grow.
I take it with. I think Andy and I both take it. It's not us. We stayed there around it, but it's really the community. It's the people that set up the PAHO project in Eclipse. It's the people that build the Raspberry Pi. It's the guys. It's ironic. Node-RED is huge, right?
Right.
Well, Nick O'Leary, and Dave Conway Jones are the two authors of Node-RED. Well, they worked with Andy and I in Hursley, and then MOD, the military department, wanted a way to have an easy way to configure the communications through their military vehicles for maintenance, right? So Dave and Nick invented Node-RED, and it's MQTT inside, and you wire up message flows, and guess what? It popped out as Node-RED, and it's still around today.
Yeah. So that's the future. And with that, Arlen, we're going to capture your time. And if you're tuning into the Energy Tech, Arlen is going to continue to push some knowledge here with us here at the Energy Tech Podcast. So this is not the only one. And so we want you to stay tuned in, and we'd love to have you. And Arlen, we are going to put some links up for the Eclipse Foundation and others, and Cirrus Link, if folks want to reach out, because I think it's important that they can, have some direct contact with your team and the group at Cirrus Link, which is always a big contributor. So stay tuned, because there's more coming from Arlen here on the Energy Tech Podcast. We're excited. Stay with us, like us, ask questions, drop some comments. We'd love to hear them.
Thanks, everybody.
Thanks for joining us here on the Energy Tech Podcast. I'm your co-host, Mike Flores.
Jeff, appreciate you guys.
I'm Arlen. Bye.